Hi, today I am going to explain a laws of motion problem, and this problem is taken from concept of physics. So, see the question: find the acceleration of the block of mass m in the situation shown in figure. All the surfaces are frictionless and the pulleys and the strings are light. So here we have two mass, twice m and m, and we have two pulleys. The pulleys are massless, no masses of the pulleys. And we need to determine the acceleration of this mass m. And here said that there is no frictional force between this mass m, and this inclined plane. So we can take the acceleration coefficient of friction is 0. And see, we have two string here. This is our first string and this is our second string. In a single string, we'll get single tensional force over the string. So we have two different strings. So we'll get two different tensional force for two different strings. Say we have tensional force T1 at the first string and tensional force T2 at the second string. Now we are going to draw the free body diagram for this figure. I have shown the tensile force for the first string. Now we are showing the tensile force at the second string. I am going to show the gravitational force due to mass 2m, and it will be 2mg since mass is 2m here. Again, the gravitational force acting on the mass m will be mg. The gravitational force always acting downward direction, and I am showing the gravitational force and its direction. Now I am taking a component of the force mg. This component is perpendicular to the plane, and we are taking another component which is parallel to the plane. And I am showing the normal force. Now see, this angle is 30 degree. So from the geometry, this angle also be 30 degree. So this perpendicular component will be mg cos 30 degree, and this component will be the parallel component will be mg sin 30 30 degree. And say the normal force is N. In this case, in this situation, the mass is moving along the inclined plane. So it may be upward direction or downward direction. But there is no motion along the perpendicular direction of the plane. There is no motion along the perpendicular. So the mass is stable along the perpendicular direction. So we can equalize the perpendicular component because this mass is stable along the perpendicular. So we can say n equal to mc cos 30 degree. Now see the hanging pulley. This one, we have two tensional force upward direction and one tensional force downward direction. Since the pulley is massless, we can write an equation along the upward direction. There is tensional force 2 into T1, and downward direction tensional force T2. Since this pulley is massless, we can write this equation. Now see this figure. If mass m moves x distance upward, then what will happen? Then this string goes upward and folded this string 2 times. That means if mass m goes x distance upward, then second pulley goes x by 2 distance downward because the string is folded 2 times. That is why the mass twice m goes downward x by 2 distance. So if you want to write a relation between acceleration of mass m and mass twice m, how can I achieve a relation of acceleration? So we know that d square x dt square gives our acceleration. So for mass m, we get acceleration by differentiating x distance, but for the second case of mass twice m, our distance is different. So we'll get that means we can write d square x by dt equal to a, and below a we get a 2. That means for a second case our acceleration will be a by 2. So acceleration of twice m mass is a by 2, and acceleration of the mass m is a. Here we have shown the acceleration of mass m, which is a, and acceleration of mass twice m, which is a by 2. Now we are going to write the equation of motion using Newton's second law. So at first see the forces along the inclined plane. See, the forces along the inclined plane are mg sin theta and t. And if t is big compared to mg sin theta, then the mass will move upward. So the total forces along the inclined plane will be T1 minus mg sin theta, theta is 30 degree. This is our total force. We are taking upward forces positive and downward forces negative. That is why negative sign come at downward force mg sin theta. According to Newton's second law of motion, F equal to according to Newton's second law of motion, total force equal to mass into acceleration. F equal to ma. Here total force over the inclined plane equal to T1 minus m sin theta. So we can write this is equal to ma, where a is the acceleration. And we can write T1 equal to mg sin 30 degree plus ma. This is our first equation using laws of motion. Now we need to find another equation using mass twice m. So in this case the acceleration is downward. Mass twice m is accelerating downward direction with a by 2 acceleration. So the downward force will be, we can consider downward force as positive and upward force as negative. The forces along the acceleration will be positive. So we can write twice mg minus T2, which is the total force acting on the mass twice m. So we can write total force equal to mass into acceleration. So here mass is twice m and acceleration is a by 2. Again we can write twice mc minus T2 equal to ma, or T2 equal to twice mg minus ma. This is our second equation. Now we are putting values of T2 from this equation. So it will be 2T1 equal to 2 mg minus ma. Now if we put the values of T1 from the equation 1 to this equation, then we can find the values of A. I am writing this equation again. 2T1 equal to 2 mg minus ma. Here I am putting the values of T1. It is mg sin 30 plus ma. mg sin 30 plus ma. The values of sin 30 is half. So we got so mg plus twice ma, mg plus twice ma equal to twice mg minus ma. So from this equation, so solving with this equation will get a equal to a equal to so we'll get a equal to z by 3 from this equation. This is the final result. So acceleration of the mass m is g by 3 and it will be upward. So a equal to z by 3. I am getting this result by solving all the equations.